All right, today we're doing lecture 11, one-step equations, and we're going to be solving these equations by multiplying and dividing. So if we were to start off with an equation like this, 5x is equal to 10, 5x is equal to 10. What we want to do with this is we want to isolate x. We want to get x by itself on the left side. So the first thing that we want to do is isolate x. So how do we do that? Well, we do the opposite of what we see. As you can see over here on the left side, I have 5 times x. So we're multiplying 5 by x to get 10. So what's the opposite of multiplying? What's the opposite of multiplying? It's going to be dividing, right? So we're going to do the opposite operation from multiplying. So we need to divide both sides by something. We can get rid of this 5 by dividing both sides by 5. So I divide both sides by 5. What happens? The 5's on the left side cancel out. Essentially, you have 5 divided by 5, which is just 1. So the variable is going to come down next. The equal sign is going to come down. And on the right side, I have 10 divided by 5, which is 2. So 2 is going to be my answer, also known as my solution. So when I get done with my solution, I put it inside a solution set. I put it inside a solution set. So that way, we know that it's the only solution for this equation. X has to be 2 for this to be true. Because if I have 5 times x equals 10, the x that would make this equation true would have to be 2. And then the last thing we do is we check our answer. So I'm going to write the word check over here, and we're going to be checking our answer for this first one. Now, when we check our answer, we always want to start off with the original equation. We want to always start off with the original equation that they gave us in the first place. So we need to see the original. So the original equation was 5x equals 10. 5x equals 10. So I start off with this original equation, and what I'm going to do with it is I'm going to substitute in our solution. Now we know that our solution was x equals 2. So all I'm going to do is I'm going to plug that in for x and see what happens. So I get 5, replace the x with a 2, and everything else stays the same. The equal sign comes down, the 10 comes down, and I have 5 times 2 equals 10, and 5 times 2 I can simplify on the left side to get 10. So I get 10 equals 10, and that is a true statement, a true statement. So I know that this one is going to work for me. That's the way that I know that 2 is the right solution. Because if I was to get a crazy false statement, like let's say 0 equals 2, well then I would definitely have an issue because this is a false statement. This would be a false statement. Because we know that 0 is not equal to 2, right? So if I was to get something false like this, I would go back to solving my equation and I would see where I made my mistake. So that's one of the ways that you can know that you actually have the right answer when you're doing these. Okay, we're going to move on to the next slide and we're going to try another one like that. X divided by 3 equals 6. So with this equation, what I want to do is I want to isolate x. I always want to start off by isolating the variable. And that means I need to get x by itself on the left side. So to get x by itself on the left side, I need to get rid of that 3 that's in the denominator. Remember, the top of the fraction is called the numerator, and the bottom of the fraction is called the denominator. So I need to get x by itself somehow. So I need to get rid of that 3 that's in the bottom. Well, how do I do that? I do the opposite operation. I need to do the opposite of dividing. I need to do the opposite of dividing, which would be multiplication. So I need to multiply both sides by 3. So that way we can get the 3 out of the denominator. So what I'm going to do is I'm going to multiply both sides by 3. So I multiply the left side by 3 on the left side, and on the right side, I multiply by 3. Remember, what you do to one side, you must do to the other. So what happens is on the left side, the 3 in the numerator and the 3 in the denominator are going to cancel each other out because we know that 3 divided by 3 is 1. I bring down my x and the equal sign. And then the last thing that I do is I do everything on the right side to simplify the expression. I have 6 times 3, that's going to give me 18, and that's going to be my solution. So now that I've made my solution set, I want to check every solution that's inside the solution set, which means I'm only going to be checking 18. So the first thing I'm going to do is I'm going to start off with my original equation. My original equation from way up here is going to be x divided by 3 equals 6. X divided by 3 equals 6. So I start off with my original equation. And what I'm going to do is I'm going to test my solution. I'm going to test 18. So everywhere I see an x, I'm going to put in an 18. So I get 18 divided by 3 equals 6. 18 divided by 3 equals 6. And what happens there is the left side is 18 divided by 3, and that's going to give me 6 equals 6, which is my true statement. So I know that my solution 18 that was in my solution set actually belongs in the solution set because it solves the equation that we started off with. Okay, so on the first slide, we did a multiplication question and we found out that the opposite of multiplication is division. And same way on this slide, we did a dividing question and we found out that the opposite of division is multiplication. So multiplication and division are opposites of each other, just like how addition and subtraction are opposites of each other. Let's try a couple more questions just like that. We're going to try this third one. X divided by -5 equals -15. And we're going to try 2/3 x equals 1/2. Okay, so for the first one up here, I notice that I'm dividing by -5. So I need to do the opposite of dividing. I need to multiply both sides by -5. So that way we can get rid of the -5 in the denominator. So I multiply both sides by -5. That way the equation can still be balanced in the end. The -5 in the numerator and the -5 in the denominator are going to cancel each other out. The x comes down as well as the equal sign comes down. And then on the right side, I have -15 times -5. And when you multiply two negative numbers, you know that you're going to get a positive number. So you're going to get positive 75. Positive 75. And that's going to go in my solution set. Okay. So here we were dividing, just like in the last problem. So I multiplied both sides by what was in the denominator. That way, I can get x by itself on the left side. Okay, let's check our answer. What I'm going to do is I'm going to start off with my original equation. And my original was x divided by -5 equals -15. So I start off with my original. And then I'm going to try my solution that I got. I'm going to let x be 75 everywhere I see an x, because I want to test out this number in my solution set. Well, I'm going to replace x with a 75, but keep everything else the same. I'm still dividing it by a -5. I still have it being equal to -15. And then on the left side, we know that 75 divided by -5 is indeed going to give us -15. So I get that -15 is equal to -15. That's that true statement that I was looking for. Let's try the next one. Down here, I have 2/3 x is equal to 1/2. 2/3 x is equal to 1/2. So the first thing I want to do is I want to isolate x. I want to isolate x. And to do that, I need to get rid of the 2/3 that's on the left side. So how can I do that? Well, I'm multiplying 2/3 by x, right? That's 2/3 times x. So I need to do the opposite of multiplication. I need to do division. So you can divide both sides, both sides by 2/3. So let's do that. I take my 2/3 x, and I'm going to divide that by 2/3. And I'm going to do the same thing to the right side. I'm going to take that fraction 1/2 and divide it by 2/3. So how does this work? The 2/3 on the top and the 2/3 on the bottom are going to cancel each other out, leaving me with just an x. And on the right side, I have 1/2 divided by 2/3, divided by 2/3. Now, whenever you divide by fractions, you want to multiply by the reciprocal. Multiply by the reciprocal. The reciprocal. So when we talk about reciprocals, what we want to do is we want to flip the fraction. We want to flip the fraction. But I'm going to keep the first fraction the same. This 1/2 right here, I'm going to keep it the same. But the second fraction, I'm going to flip over so I can get its reciprocal. And if I flip over 2/3, it'll be 3/2. So all I did was I flipped over the second fraction right here. I flipped it. So that way I can get the reciprocal. But one thing I am going to change is the division sign that we started off with is now going to be a multiplication symbol. So now we're multiplying by the reciprocal. So what happens when we multiply these two fractions? Well, we multiply the tops and we multiply the bottoms. 1 times 3 is going to give me 3 on top, and 2 times 2 is going to give me 4 on the bottom. So this is going to be the answer in my solution set, 3/4. And to quickly check this, what we want to do is we want to start off with our original equation, and then what we want to do is we want to put in 3/4 for x. And I'll do that in red. So I have 2/3 times x. Well, for x, you know we're going to use our solution, right? I'm going to plug in 3/4, and I should get 1/2. Well, what happens here? The 3's are going to cancel each other out since 1 3 is in the top and 1 3 is in the bottom. and I get 2 over 4. Well, 2 over 4, isn't that the same thing as 1/2? Yes, it is. So I get that true statement. 2/3 times 3/4 is 1/2. Okay? So that is one of the ways we can solve an equation like that. And what I'm going to do on the next slide is I'm going to do one more example like that, but I'm going to show you a little bit of a quicker way to get it done. Okay, let's move on to the next slide. Let's try this one. 3/4 x is equal to 1/3. 3/4 x is equal to 1/3. So with this problem, notice what's happening on the left side. I have 3/4 being multiplied by x. So what I need to do is I need to do the opposite of multiplication. I need to divide both sides by 3/4. But notice when I divide by a fraction, I'm really just multiplying by the reciprocal. Well, what's the reciprocal of 3 over 4? Well, the reciprocal of 3 over 4 is going to be 4 over 3. 4 over 3. Notice all I did was flip the fraction so that the numerator is now the denominator, and what was the denominator is now the numerator. I need to multiply the left side by 4/3, and I need to multiply the right side by 4/3. So that way everything will be balanced in the end. So what happens here? These 3's that are across from each other get cross-canceled, so those 3's are gone. Also, the 4's that are across from each other, they get cross-canceled, so the 4's are gone. So now I'm just left with the variable x, since everything else on the left side has gotten canceled out. I bring down my equal sign as well. And then on the right side, that's where all the numbers end up. And I have to do all the math on the right side. So what's going on the right side? Well, I have 1/3 right here, and I have 4/3 right here. We're multiplying two fractions together. So I'm going to multiply the tops together, and I'm going to multiply the bottoms together. The tops are going to give me 1 times 4, which is just 4. And then the bottom is going to give me 3 times 3, which is just 9. So therefore, 4/9 is going to be our answer. And I put that inside the solution set. The solution set. Okay. So now the last thing I want to do is I want to verify that 4/9 is the solution. So we're going to check on the bottom of the slide. Let's go ahead and check. So whenever I check an answer, what I want to do is I want to start off with the original equation. The original equation is in red this time. So I have 3/4 x. 3/4 x is equal to 1/3. 3/4 x is equal to 1/3. Okay, so I start off with my original equation, and I take my solution, which was 4/9, and I want to plug that in for x. I want to plug that in for x, but I'm going to keep everything else the same. So the 3/4 down here is going to stay the same. I'm going to be multiplying by 4/9 in parentheses. And then on the right side, I should still have 1/3 when I get done with everything. So what happens when I multiply on the left side? Well, you notice that the 4's are across from each other. And since there's a 4 in the numerator and in the denominator, those are going to cancel each other out, because essentially 4 divided by 4 would just be 1. I also have 3 across from 9. So what I could do is I could reduce 3 over 9 down to 1/3. And the way I would do that is I would divide by 3 on the top and the bottom. So if I divide by 3 on the top, I'm going to get 1. If I divide 9 by 3 at the bottom, I'm going to get 3. So the only thing I'm left with at the top is going to be a 1. But the only thing I'm left with at the bottom is going to be a 3. And that's going to give me that 1/3 equal 1/3 true statement that I was looking for. So I know for a fact that 4/9 is going to be the only solution to this original equation. Okay. And that is basically it. I will keep this up there for about a minute longer, and then on the next slide, we'll talk about what's going to be due on Sunday. Okay, so what's going to be due on Sunday? Well, you have 2 assignments, so let's talk about them. All right, you've got your equations classwork, and you've got your equations quiz, right? 2 things. So what you need to do for all of the questions is, first of all, show your work. Show your work. I can't give you credit without that. I need to see what you're doing. The second thing you need to do is show your solution set. I need to see what answer you got. So show your solution set. And then the last thing you need to do, of course, is check your work. Check your work. So I can't give you credit without all 3 of these. Okay. And that is it. Class dismissed. If you have any questions about today's lecture, or if you have any questions about the classwork or the quiz that you were confused about, please stay after and put your question in the chat box, and I will get to you very soon. All right? Today is Thursday, so I will see you guys next week on Tuesday. Have a very mathematical day.